So we're going to continue with 10.05 logic gates 2, page 236, 237. So now we're going to take an example for combining the logic gates. Here, for example, we have this circuit. It's for security lamp. What is the security lamp? The security lamp is you put outside your house, and when someone comes, the lights will light on it automatically. So when it's dark, for example at the night, after the midnight, some thief or any other thing will come near to your house, the light will light up automatically. How does that happen? We have here the light sensor to make sure the light will go just in the night. Okay? It's connected to logic gate NOT. And then we have body heat sensor. That means this sensor will give a high. So we say the 0 is what is low and 1 is high. When will give us 1 when somebody comes. So that's the job of the body heat sensor. It's both connected to logic gate and the output of logic gate AND is connected for the relay, and the relay for the lab. So the relay is just a switch for heavier load. Okay. So now if this will give us 0, after the logic gate will give us what? 1. And this will give us 0 to the AND or 1 to the AND gate. So the AND gate, the output to the relay, we say we turn off or switch on the lamp. Turn on or switch on the lamp. So if I put 0 here, it will become 1 here. And if someone comes in the body heat, the AND will what? Just in one case, 1 and 1 will give us 1, right? So going back to the relay, it will switch on, make the electromagnetic, will pull the switch and turn on the lamp. So try to do this truth table for A, B, and let's say here is Q, the out. So try to do this truth table. Now, we have here we saw NOT and AND. So this two combined logic gates. So you have one combined logic gate, it's called NAND. That means NOT AND. So it means the NOT and the AND. So if you remember the AND gate, everything is 0 just in case too 1 or too high. The AB, the inputs, will be what? The output will be what? Will be 1. Remember we say just is like multiplying. But here it's totally the opposite. Why? Because it's not AND or NAND. How we can know the difference between them? We look, okay, this is just like this. How can I know the difference? Here we have the small round circle. That's mean it's NAND. Okay? So let's say this symbol is for the NOT. Like this. So they take just the circle from the NOT. Now we go to the truth table of the NAND. It's all 1, just in one case it's what? It's 0. Exactly the opposite of AND. So remember AND, we say multiplying, anything you multiply by 0, it's 0. 0 multiplied 1 is 0, 1 multiplied 0 is 0, right? So 1 multiplied 1 is what? Is 1. So in this case we say it's the opposite, so just in this case will give us 0. So 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1 will give us 0. Okay? Now here we have the same, but it's for NOR. Not OR. Remember the OR? The OR we say just like the sum. 0 plus 1 is 1, 1 plus 0 is 1. Okay? Now it's not You can see the circle also. That's mean totally the opposite of OR. That's mean every case in OR, every case is 1. Just when 2 zeros, it's 0. Here's the opposite. Every case is 0, but just when it's 1, just when it's 2 zeros, that will give us 1. So let's check the truth table. 0, 0 will give us 1, like we say. 0, 1, 0, 1, 0, 0, 1, 1 will give us also 0. Now we have here this circuit for combined 3-gate AND. But here we have something that the both of the input are what? Connected to each other. That means if this 1, both of them will be 1. Okay? And if this 0, both of them will be 0. The same here. If this 1, if A1, both of the A's, the input for the logic gate, NAND, you see, it's all NAND. NAND, you can see the circle, NAND. Okay, not AND. So you notice the circle, that means what? They're what? They're negative. So if we put here 1, that means will be 1, both of the input will have the out C going to another AND. Here is the same. If we put 1 or 0 on B, will be the same thing for both of the input. Then connected to D, the output of NAND of B. Now the NAND, the last one, is combined between the output of A and the output of B will go as an input for NAND. Okay? And here is the output Q. So let's try to do it together. So they give us just 0, 0, 1, 1. Why? Because if I put 1, why it's have just 2 cases? Because if I put 1 here, it will be the same. If I put 0, it will be the same. So I cannot put 1 and 0. Okay? Like the last truth tables. Like this one. So the 1 and 0 just like to do the qualification in case this, in case this, in case this. Okay? That's the job of the truth table. So 0 or 1. If I put 0, it's NAND. Let's go to the NAND. So we have 2 cases. 0, 0, 1, 1. When I put 0, 0, it's what? It's 1. When I put 1, 1, it's 0. The B is the same, even it's 0, 0, or if it's 1, 1, right? The same, it's also NAND. Go back, 0, 0, and give us 1, and 1, 1 will give us 0. High or low. Now Q is what? It's C and D. So we find out C and we find out D. Now C and D is what? 1, 1 or 0, 0. 1, 1 is what? 0. Right? And 0, 0, here you can see it's 1. So this is the truth table for this one. Now, the last thing we're going to talk about today is what is the gates and the logic gates, of course, in the microchip. So open your book, page 237. Gates, more gates and computers. You can see this black thing, black square with the circuit, the green one around it. So what this is actually, it's a microprocessor. So each processor have more than 100 million logic gates, but it's built up with what? With the microscopes, like microscope way. So it's very, very, very tiny. Okay, it's just like this in this size. It has more than 1 million gate and transistors and a lot of other components. It's just about made from silicon in a very special way. can YouTube that and you find how they make the microprocessors, and it's very interesting. So that's our video today. Thank you for good listening. Take care of yourself and don't forget to wear your mask.